So there's no samples like this within the lesson, so in order to make sure you guys understand this, we're going to work the odds together, and that will give you all the help you need for 2, 4, 6, and 8. Okay? Now, just to start with, I want to work the sample that they have. I know you could pretty much see it, but I want to make sure that we talk through it together. Is that okay? All right. The sum of a number and its reciprocal is 26/5. Okay. Give me, ignoring that for a minute, give me a number. Pick a number.
11.
11 it is. What would 11's, Percy, we're just kind of shooting at the hip here. What would 11's reciprocal be? That's its opposite. 1 over 11. No worries. So this is the number, and this is its reciprocal. The reason I'm showing you this is you have to remember that what we're working with today is going to follow this pattern, okay, with numbers and their reciprocals. Let's look at the sample. We're on page 306, bottom third of the page. It says the sum of a number and its reciprocal is 26/5. So you all seeing where I'm at? Mm-hmm. So if I called the first thing the number n, just like we called 1111, what would n's reciprocal be? Just like what would 11's reciprocal be?
1 over n.
Good. So again, that first sentence says the sum of a number and its reciprocal is 26/5. You guys seeing where I'm getting this information from? Mm-hmm. Okay. And the question says, what is the number? Well, here we are right where we started yesterday, and that is, how do we solve equations where there's variables in the denominator? Well, what I taught you guys yesterday is the easiest way is to clear the fractions. And to clear the fractions, we multiply by the lowest common denominator. And the lowest common denominator is the largest power of any factor showing. Percy already said it's 5n. So, multiplying everything by 5n, and I'm going to throw it over 1. There it is. So far, still good?
Yeah.
Okay. And in the first position, we have 5n times n, 1 times 1, so you end up with 5n squared. In the second position,
Plus 5.
plus 5 because the n's canceled. And what canceled here?
The 5, so it's just going to be 10.
Bravo. Okay. To solve, we are going to subtract that 26n over, factor, and solve for 0. It's going to look like this.
I remember these.
Mm-hmm. Okay, I subtracted that over. You guys with me how that came over there? Okay. To factor. Is it a perfect square? No. Is it a difference of squares? No. Factors of A and C, whose sum is that? So factors of positive 25, whose sum is a negative 26. How about negative 1 and negative 25? Awesome. Now, we've got a 5 here and a 5 here. So frankly, it doesn't matter where I put the 1 and where I put the 25. So I'm going to do 1n here, 25n here. Remember, the n stays attached. Group, boom, boom. and we're going to factor. We'll pull out n, 5n minus 1. And how about minus 5? And n minus 1. Combining the two items that share, how about 5n minus 1, Mrs. Myers? Combining the two items that share that factor, it'll look like this.
Allison to the gym. Allison sent to the gym. Thank you.
Solve for 0. So you should have a 5 after we added that over. After we add over our 1 and divide by 5, we should have a 1/5. You guys seeing that? And remember the question says, the sum of a number and its reciprocal is 26/5. What are the numbers? Well, it's going to be 5 and 1/5. And actually, if I add this together, this would be 25 over 5. And this is 1 over 5. If I add those things together, do I get 26/5? So you know you're correct. That's the sample. Number 1 is very similar. The sum of a number and its reciprocal is 25/12. So x is the number. What will its reciprocal be?
1 over x.
Mm-hmm. Lowest common denominator? Mm-hmm. 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 Good job. Zero it out. You're going to love this. Factors of 144, positive. Factors of 144 whose sum is negative 25. Now, lucky for you, I've already figured all that out, but if you had to, you could. So we're going to factor it, because it's not a perfect square, it's not a difference of squares. To come up with a positive 144 that adds together to get a negative 25, it's a negative 16x and a negative 9x. Okay? And if you were playing with your calculator, you would do 144 by 2, 144 by 3. You would keep listing all the factors until you came up with factors of a positive 144 that add together to equal that negative 25 in the middle. Okay? So shorthanding it here, I already did it. Here are your groups. How about 4x, 3x minus 4 and negative 3? 3x minus 4. Because we end up with the same things here, obviously we know we pulled out correctly. If you pull out a positive 3 here, if you pulled out a positive 3, you would have a negative 3x and a positive 4. So you would know you had to flip that sign to maintain the integrity of the signs here, matching with those. 4x minus 3, 3x minus 4, solve for 0. Add 3 divided by 4. 4x minus 3, that's this.
Oh.
3x minus 4,
Yeah.
that's that.
Yeah.
Solve both of them for 0. Add 4 divided by 3. So those are your two answers, and let's see if it answers the question. The sum of a number and its reciprocal. Find the number. So this is the number, this is its reciprocal. Or you could say, this is the number, this is its reciprocal. In any case, these are the two numbers that they're describing for us. Okay? That is number 1. Number 3. The sum of the reciprocals of two consecutive odd integers. First of all, give me two consecutive odds, x and x plus 2. Great. X plus 2, right? But they want us to add together the reciprocals. So throw 1 over it. Okay? Do you guys see how I established that? Those are the numbers. Throwing a 1 over it makes it the reciprocals. The sum of the reciprocals of two consecutive odds is 8 over 15. Find the integers. Since they told us it's integers, can it be fractions?
No.
No, ma'am. Okay, lowest common denominator. Greatest power of any factor showing. 15 times x plus 2. This is showing, and this is showing. And none of these are within the other. You're saying, well, Mrs. Myers, x is part of x plus 2. Yes, but it can't be pulled out. This is a complete unified entity, kind of like marriage. You can't separate anything out of this. Okay?
I don't know. That's the main one. This math lesson is debatable now.
15x plus 2. 15x plus 2. 15x plus 2. So far, so good? I know it seems squirrely. Well, what could you pull out of both of these? 1. Nothing. So this is a complete unified factor. What could you pull out of this? 1. You could pull a 3 and a 5 out of this, or a 1 and a 15 out of this, but that doesn't change anything. Start reducing or canceling. And in the first position, and I'm going to be real slow about this because I don't want to make any mistakes. So the x's cancel, leaving me with 15 times x plus 2. Added to, the x plus 2's cancel. 15x it is. That one's easy enough. The 15's cancel, leaving me with 8 times x plus 2. Okay? Just to make sure I didn't make any screw-ups. I didn't do it all in my head. 15x plus 30. Okay, don't forget you got to distribute that over both. So, I always, when I have a quadratic, that's to the second power, I want to have a positive, if at all possible. And since right now it's positive, I'm going to bring all this stuff over to here. Okay? What is the sum of 15x and 15x?
30.
Okay. So I'm going to subtract 30 over. You guys see what I did here?
Yes.
Moving the constant over. Looks like that. 8x squared minus 14x. Factor and solve for 0. Factors, what's 8 times negative 30? Negative 240 is right. So factors of negative 240 who have a sum of negative 14. So you would hunt and peck for a while, but hopefully you would find that it is a negative 24 and a positive 10. Remember, you keep your x's in there. Okay? You guys okay so far? Group factor and solve for 0, or group, pull out and solve for 0. So 8x, x minus 3, plus 10, x minus 3. Again, I wanted to keep x minus 3, so that's why I chose a positive 10. If I made the 10 negative, it would be negative x plus 3, and that's not what we want. So 0 equals 8x plus 10 times x minus 3. Let's solve for 0. X minus 3 is 0. 8x plus 10 is 0. X is 3. That's easy. 8x is negative 10. X is negative 10 eighths. 2 goes into that 5 times. Okay. Which of these can I automatically throw out based on the question? Why can I throw 5/4 out negative? Because it's not an integer. Boom. Your answer, 3. So 3 is x. What are the integers then? 3 and 2 consecutive odds. Good. Okay, x and x plus 2. That's 3. How are you guys doing? You hanging in there?
Yeah.
Okay. 5 and 7, last 2. The numerator of a fraction is 1 more than the denominator. So, the numerator of a fraction is 1 more than the denominator. Look at how I just translated that. I don't know what the numbers are, but I do know the top is 1 bigger than the bottom. Okay? The numerator of the fraction is 1 more than the denominator. That's the first sentence. If the numerator and the denominator are both increased by 2, okay, I'm doing this in red just so that you can see, that's the second thing. The new fraction will be, so that's is, with the increase, what I get is 1/4 less than the original. 1/4 less than the original was x plus 1 over x, right? Look at this. The numerator is 1 larger than the denominator. If I add 2 to both the numerator and the denominator, the new fraction is 1/4 less than the original. And the original was what I had in blue. And their question is, what's the original fraction? Okay. So by adding 2 to the numerator, I get x plus 3. Would you agree? By adding 2 to the denominator, I get x plus 2. Now, I'm going to work all this. And it looks like that. So, greatest power of anything showing. X plus 2 appears 1 time. X appears 1 time. 4 appears 1 time. Percy, you are right. X. X plus 2 and 4. Here we go. X. X plus 2. 4. Multiplying each piece by that. Okay. Does everybody see where I got all this from so far?
Yeah.
I know it's a lot of thinking. The x plus 2's cancel, leaving me x times 4 times x plus 3. Just going to build it like that so I don't make any mistakes. The x's cancel, leaves me with 4 times x plus 2, which is 4x plus 8, multiplied by x plus 1. Okay? look at this again. The x's cancel, leaving me with x plus 2 times 4, which I multiplied right here, times x plus 1. Okay? Anybody stuck or lost? The x's canceled. Okay. Minus the 4's cancel. Now remember, this negative is going to apply to this entire piece here, x and x plus 2. So, minus whatever the result of x plus 2 is. Okay, I want to make sure that we don't forget that this gets distributed over all of this once it's multiplied out. And it'll look like this. 4x squared minus plus 12x equals, let's FOIL this mess. 4x times x, 4x squared, outside positive 4x, inside positive 8x, last positive 8. Minus, this is x squared plus 2x, right? Since this minus applies to both of these pieces, that means this becomes a negative x squared, and this becomes a negative 2x. Does everybody see how I distributed that negative over those two pieces? Because we're subtracting that entire chunk. Now let's combine all the chaos that we have over on the other side of the fence. We've got 4x squared plus 12x equals 4x squared, 8 and 4 is 12x. Okay, look at that big long mess. Should we start collecting some stuff? One thing to keep in mind is that when you have the exact same item on both sides with the same sign, they cancel each other out. Think about it. If I subtracted this over to here, it would be 0, right? This over to here, it would still be 0. Same way with this, right? If I subtracted this over to here, it would be 0. Or the other way. Same idea. Okay? So, I'm going to cancel those and that, which leaves me this. 0 equals negative x squared minus 2x plus 8. There's your positive 8. There's your negative x squared. There's your negative 2x. Now, I don't know if you guys recall or not, but when working with a quadratic, the first position, the a value, I prefer to have that be positive. So I'm going to add everything to the other side. Plus x squared plus 2x minus 8. Okay? So that means I have, I'm going to run out of room here, so I'm going to flip to the back. I have x squared plus 2x minus 8 equals 0. Factors of negative 8 who leave me with a positive 2 sum. X plus 4, x minus 2. So x is negative 4, x is positive 2. Okay. So, that doesn't answer the question. It tells me what x is, but what do they want to know? They want to know what the original fraction was. Do you guys remember the original fraction was, the numerator was 1 larger than the denominator? So I can take either of these and plug it in. Either one would work. How about negative 4 plus 1 over negative 4? What do I get? Negative 3 over negative 4, which is a, what? Positive 3/4, so that's not right. What's wrong with this? It's a positive, right? And is this number bigger than this number? 3 is bigger than 4?
No.
So you got to throw it out. 4 has to be thrown out because the resulting fraction does not have a numerator that's 1 bigger. Okay? Let's try the other one. 2 plus 1 over 2. 3 halves. Is the numerator 1 larger than the denominator? There's your answer. So when you solve it, make sure that you answer whatever it is they want. Number 7. Number 7 actually isn't too hard. Number 7 says, the sum of two numbers is 10. So in order to have a number that has a sum of 10, you have to illustrate it like this. Everybody looking at it? That means this is the first number, and whatever that is plugged in here gives me the second number. Okay, throw me a number between 1 and 10.
7.
7. So if n is 7, then what's 10 minus 7? Do those two numbers have a sum of 10?
Yes.
So that is why this needs to be your representation for the data that they're throwing at you. Okay? The sum of two numbers is 10, and the sum of their reciprocals is 5/12. So what is n's reciprocal? What's 10 minus n's reciprocal? Try the other way. 10 minus n over 1 is 10 minus n. Good. The sum of their reciprocals is 5/12. Here's another one. Look at all this. Lowest common denominator is the greatest power of anything showing. N times 10 minus n times 12. Got to multiply all that in there. N, 10 minus n, 12. Okay? All of this gets multiplied by each piece. Okay? And in the first position, the n's cancel out. Okay? Which leaves me 12 times 10 minus n. In the second position, the 10 minus n's cancel out. Leaves me 12n. And in the third position, the 12 cancels out. Leaves me n, 10 minus n. Okay? So I just wrote what we were multiplying one time, but I went back and canceled in my mind. If you can do it that way, that's great. If you can't, that's fine too. So to finish it up, 120 minus 12n plus 12n equals 10n minus n squared. Times 5. Forgot to multiply it by 5. Yeah. So, that leaves me 50n minus 5n squared equal to all this. The 12n's cancel, don't they? Okay, see that? Equals. Yep, but we want to keep our quadratic, which is the item squared, positive, makes it easier to factor. So I'm going to add it all over to here, and it's going to look like this. Because we want to keep it in order. All of this equals 0. You're saying to me, this is Myers. 5 times 120, whatever that is, those things have to equal a negative 50. Remember when you guys were taught to factor, you were taught to look for anything that could be pulled out of all three. Is there anything that can be pulled out of all three?
Tyler and Ginny to the office, please. Tyler and Ginny.
5. So that means 5n squared minus 10n plus 24 equals 0. Okay? Factors of 24 positive that come together to keep equal a negative 10? Yep. Okay. Solve all three factors for 0. Remember, I pulled that 5 out. 5 equals 0? Well, that's false. You can automatically throw that out. N minus 6 equals 0, so n is 6, okay? N minus 4 equals 0, so n is 4. Awesome. What do we have? The sum of two numbers is 10, and the sum of their reciprocals is 5/12. Is the sum of these two numbers 10? I bet you if we added 1/6 plus 1/4, converting them both to 12ths. 2/12 plus 3/12, is that 5/12? So we're correct. Just by checking it, I was able to confirm it.